The back, yeah? Yeah, okay. Just want to wave at me. We're ready? Perfect, okay. Can everybody hear me okay? Yeah, perfect. Looks like it's on now, finally. Okay, great. First off, thanks a lot for coming, everybody. I really appreciate your time. Thanks for attending Build and talking to us about data for a little while. As you saw in the keynote, we've been spending a lot of time talking about data, about a lot of the new data services that have come into Azure over the last couple of years. And so what I wanted to do in this session was spend a little bit of time talking about how you can compose and use all of those services together to create what we call a data pipeline. What we found was that a lot of solutions people were trying to build to get the most out of their data followed a typical pattern. We call it a pipeline. You might hear it called a data flow, a data integration project, et cetera. But what we're going to look at in this talk is how you can reach out and collect all of the data that's interesting to you, process it, transform it, analyze it, maybe do predictions based on it, and then get it where it needs to be to drive analytics and BI or drive experiences in your app. And so that whole flow we talk about as creating a data pipeline. What we're going to do in this session is talk about how you can use all of these new analytics services in Azure, combine them together to create this end-to-end flow, but not only get it created, get it done in a way that it's sustainable, you can monitor it, you can manage it. If you check in an issue, you can quickly debug it and move on from there. So we're going to spend a lot of time looking at how we go about creating these types of analytics solutions. Remember, submit an eval. Wasn't expecting that to be there. In terms of agenda, we'll talk a little bit about what and why. From a what perspective, it will be what services can you use, what is available today, et cetera. Why might you think about composing these services in different ways, what use cases you can target. And I'll spend most of the session today talking through a specific use case that we see built out in Azure a fair amount. I've called it customer churn analysis. It's as simple as any subscription service, any membership, et cetera, that you might be providing to your customers. You want to know how much of that your customers are using. Do they like it? Do they not like it? Are they likely to use less? Are they likely to cancel their subscription, et cetera? You want to analyze all the data available to you to make these informed choices. And so we'll look at the customer churn analysis example as just kind of an example we'll use across the talk. We'll actually build out that pipeline, see how it works, et cetera. And then we'll talk about a few other common use cases. But the interesting thing is the patterns that we'll look at, how to bring the services together, can be applied to many more use cases than this. We'll just use this tangible, concrete one to kind of govern the talk today. And then lastly, I'll talk a little bit about roadmap and then open it up for questions at the end. So with that, before working in the Data Factory service at Microsoft, I spent time launching our HDInsight service. And these were the types of conversations we've been having with customers over the last 2 years. And it's really been an interesting set of conversations where people are saying, look, there's all kinds of data out there. Either I'm collecting it, I'd like to be collecting it, I'd like to be working with it, I'm kind of working with it, to answer a bunch of different questions, whether they're traditional BI questions over more data or different sources of data, all the way through to predictive questions where I'm trying to use data to predict what's going to happen in the future. And as I mentioned, we'll focus on the kind of predictive customer churn scenario. And I'll touch on a few more throughout the talk as well. But we're really going to dive into the customer churn scenario so you can see the pieces and parts, how to go about building an analytics pipeline on Azure, composing all of the various services together. So with that, let's kind of jump into the meat of the talk. And a question we get asked a lot is, you guys launched this service called Azure Data Factory. Why the heck did you call it Data Factory? What are you trying to do with this service? And the reason for that was that a lot of the analytics solutions we saw people building really followed the typical flow that you'd see in an assembly line in a manufacturing plant, which is you have to collect all of the raw materials you think you may need to your loading dock. You're then going to assemble or create an assembly line. That assembly line is going to work on those raw materials. It's going to have all kinds of fit-for-purpose machines that work on that material, transform that material, combine it, and finally you've got some type of finished good. And then lastly, you want to deliver that finished good to your consumer. And again, somebody's finished good might be another person's raw material, and the process repeats itself. And so you end up with at least in the manufacturing perspective, a pipeline that looks something like this. If we were to overlay more data words on top of this, We talk about our data sources are our raw materials. We need to ingest and collect that data from those data sources, whether they be on-prem, data coming from SaaS apps, data coming from the cloud, whether it's a relational database, a Hadoop source, a file share, et cetera. All of that data we want to be able to work with and address for analytics purposes. So we think about ingesting all of that data. We want to transform and analyze, regardless of shape, speed, et cetera. We want to be able to work with, munge that data. From an analysis perspective, we might do simple things like trying to aggregate and report on data all the way through to more predictive things like using data to predict particular outcomes. And then lastly, you want to be able to publish your data. In this particular case, or in the sense of this talk, publish means taking that finished good that you've produced from your data pipeline and getting it to where it needs to be for most efficient consumption. What I mean by that is you might be processing data with Hadoop, and you want to get it to a relational database or a data warehouse back on-prem to connect to your existing BI infrastructure. It could mean loading a NoSQL store or a search index with some interesting data that's been generated by your pipeline so that applications can consume it. We see all kinds of interesting scenarios for these analytics pipelines that are ingesting, transforming data, and loading it into places for all kinds of interesting consumption. So if we look at this predicting customer churn scenario in a little more detail, I've picked two data sources that we'll use as our raw materials for the talk. One is a bunch of log files. The other one is more structured data. And what we'll do is we'll build out an analytics pipeline that mirrors what you might do if you were like a telco or a mobile phone carrier, where you've got people subscribe to your service. Everybody's got a phone in their pocket, so I figured this would be a good one that everyone can relate to. But again, the pattern applies very broadly. And so our scenario will be you've got a telco. From a very high level, the way it works is we're constantly making phone calls. That's being routed through all kinds of infrastructure. That infrastructure is actually logging everything about our phone calls, from the numbers that we call, from the various SIM cards, through to the length of our calls, through to the drop of the call, through to the quality of the call, through to the route that the particular call took to connect me to you, et cetera. All of that data is being logged. What if we could mine that data to extract insight from it? So the first raw material for our pipeline is the actual log files coming off the cell infrastructure. The second raw material that we'll use for our pipeline is more structured information. Every business has data warehouses today, right? You've seen all of our announcements about warehouses. Every business has warehouses where you keep that structured information. In this particular case, for our mythical telco, we've got a customer list, or your authoritative customer list. This is very likely kept in an on-prem warehouse somewhere that lists who your customers are, when did they sign up, how old they are, all the typical stuff you have when a customer signs up to your service. And at the end of the day, what the telco is trying to do is come out with a finished good that looks more like this. And being a data geek, I consider this a finished good. Another data set. Not being a data geek, that's probably a finished good. But the idea here is to create a pipeline that can ingest that data, transform that data, predict based on that usage data, and tell you which of your customers are more or less likely to churn, where churn here is defined as use less of your service or product or cancel your subscription with your service or product. And so what we want to be able to do is ingest that data, transform that data, run machine learning on that data to come out with this finished good, and then do it repeatedly, right? Because every month we're all making calls, we're all making decisions on how we feel about our cell phone coverage and everything like that. And so what we'll do is we'll create a pipeline that's running all the time. And the pipeline is going to be working over a month's worth of data at a time. So we're going to create a time-based pipeline where every month we'll be ingesting this input data. Every month we'll be analyzing and transforming that data to come out with this data set, which is effectively the customer's likely to churn next month. Okay? And again, being a data geek, I consider this a finished good. But more than likely, the actual finished good in something like this will be a report that your marketing team, your customer engagement team may want to pick up and say, okay, these are the people likely to churn. I may want to target them with special offers. I may want to reach out to them and get ahead of customers before they start canceling their subscription or reducing their usage plans. The interesting thing is this pattern is actually something we've extracted from a set of our customers in production today with Data Factory and HDInsight and Blob Store, and we've just generalized it for the talk. So it's something that we've got a fair amount of experience with. I've just kind of generalized it to the telco space because I thought everybody could relate. So with that, given this is build, let's kind of dig in and see how a pipeline like this can be built using the services that are available in Azure today. So first step, we need some raw data. That's supposed to be a cell phone tower. I apologize for my poor art. But the raw data here is cell phone towers all over the place that are collecting these log files. Typically, these files are called CDR files, called detail records. They get pushed to all kinds of file store infrastructure, whether that's file stores in an on-prem situation, FTP servers, et cetera, but they get logged. Then we've got a customer table in an on-prem data mart, data warehouse, et cetera. And what we want to be able to do is collect all of that data, and we want to put it into a place that we can run analysis on it at scale, regardless of the shape, size, or et cetera of the data. And so a great way to do that today is to use Azure Blob Storage. Just ingest all of the data into Azure Blob Storage. Built into Azure Data Factory is a globally available data movement service that knows how to reach back to on-prem sources and get data, knows how to reach to file shares and get data, move data among blob stores. And so ingesting data can be facilitated via the globally available movement service in Data Factory. You'll push that data into Blob Storage. If anybody's not familiar with Azure Blob Storage, it's effectively file store in the cloud. You can put anything in it. It's scale out, highly available, and it's dirt cheap. And so you start to be able to take this methodology or mentality of collect everything. This is kind of the loading dock, if you will, of your pipeline or your assembly line. Collect everything into Blob Storage. You may have a scenario for that data out of the gate. You may learn about a new scenario for that data down the line. Collect everything. It's now kind of economically possible to go do that. It's really cheap to put things in Blob Storage. Once you've collected stuff, your next step is to actually create, just like a manufacturing plant, create your assembly line. What's going to work on this data? And this is where it's pretty fun to be in data right now. Obviously, I'm in data, so I say that. But it's a really fun time because there's a lot more tools that we have available than we used to. And so now it's not just, OK, can I represent that data in SQL? But I can have a bunch of tools that are fit for purpose depending upon what I want to do. And with Data Factory, what we can do is compose all of those fit for purpose tools to work on the data as we need. And so the first thing we're going to go do is create a pipeline. And that pipeline is going to start by using some Hadoop processing to process these very large collection of log files. If you think about it, think of every call anybody's making in the United States for a particular carrier, being able to ingest all of that data and process it monthly to come out with one row that says, Mike Flasco talked this many minutes, he had this many dropped calls, he had this many calls internationally, domestically, et cetera. That's what Hadoop is going to do for us in this particular stage. So our first stage to kind of transform and combine the data is going to aggregate all of those call logs to generate literally one record per customer per month. It's going to combine that data with the on-prem reference data, which is our customer list. So it's not just SIM card talked this long, but it's Mike Flasco of age, I don't know what I put for myself in here, 32, talked this long, he had this many dropped calls, et cetera. And so now you can get a very personal sense of exactly what your customers have been doing and the experience they've had with your service. Once we've got that data, we've prepared it, we've transformed it with HDInsight, the next step will be to take that output data, which I've called here the customer call details, and push that output data into an Azure machine learning model. And we're going to use a machine learning model that's available in the machine learning gallery. What it's going to do is take that data as input, one row per each customer, and it's going to look at all that data and compare it to training data we've used for customers who have canceled their subscriptions in the past. And it's going to predict which customers are likely to churn. Basically, which customers are more or less likely to cancel their subscription or use less from this particular telco. And then that's going to output a data set called customers likely to churn. Lastly, you may want to move that data set. You may want to take it out of Blob Store and push it back on-prem to your data warehouse for reporting. You may want to take that data set, push it to another store for sharing with a partner, whatever the consumption pattern is for this particular piece of data. In this case, what we're going to do is move the data to a cloud database in Azure DB. Going forward, the Azure Data Warehouse service will be a great option, and it'll be natively supported by Data Factory. And then lastly, what you want to do is create a visualization, right? For me, the table in SQL is finished good for me, but for your marketing team, your customer engagement team, they probably want a report. And so a finished good here would be some type of report you've created over top of that data. And so effectively, this is what we want to have happen. We want to work with the actual log files from how people were interacting with their phones and transform that into a report about are you or I more or less likely to churn based on the experience we've had with the service. And then we want that to run every month. And we want it to run reliably every month. And we want it to be able to improve it and increment on it every month. And so we want to be able to run this whole thing as a single pipeline, operate it as a single pipeline, and have it highly available. I've been using the word Data Factory a lot throughout my description. Data Factory is a new preview service we have in Azure that effectively lets you model this entire data flow as what we call a pipeline in Data Factory. So I'm going to introduce you to the 3 key concepts that's in the Data Factory service that allows you to compose these Azure services together into these types of data flows or pipelines. The first key concept in Data Factory is called the data set. A data set is just that. It's a piece of data you want to work with in your analytics pipeline. A data set could represent a table in a database, a piece of structured data. A data set could represent a bunch of log files that you have in blob storage that you want to treat as a single data set. It really can represent any piece of data. Data set is just a piece of metadata in Data Factory. It's an assertion about a piece of data at a particular location. Next key concept in Data Factory is called an activity. An activity is a processing job. It's something that works on the data. It either moves data, transforms data, shapes data, does a prediction on data. And so in our scenario today, the activities in our pipeline will be some Hadoop activities, some Hive and Pig work, followed by the execution of a machine learning model, an Azure ML model. That's also considered an activity. And then lastly, we'll move the data to Azure DB. And that movement step is also considered an activity in Data Factory. And the interesting thing, again, is that activities are just assertions of work that is going to happen on particular services. The Data Factory does the job of orchestrating the work among the services, the scheduling, the monitoring, actually making the pipeline flow. And lastly, you can organize your activities into kind of logical sequences. We call those things pipelines. A pipeline is just an ordered set of activities, and it's a logical grouping. You think about how you organize a set of classes into a DLL or methods into a class. It's the same kind of thing in Data Factory. You organize a set of steps into whatever granularity you want. You could have a pipeline of 30 steps. You could have a pipeline of 1 step. It's completely up to you. It's just an organizational tool for you to say, you know what? This HDInsight job followed by this machine learning model invocation followed by this move, this particular set of steps. This is my calculate customer churn pipeline. And that allows me to just kind of reason about the things in a little more organized way. And so with that, think back to the analogy to the factory floor, to the assembly line. These are the core steps that you see in a lot of these solutions. Collect the data from the data sources that you need, connect to them, ingest them, transform and analyze, publish the data. So you'll hear me reference that structure a fair amount throughout the talk today. So with that, hopefully I've set the stage on what we're trying to do, how the various Azure services will be used, and what role they'll play along our pipeline. And now what I'll do is I'll jump out of slides and get into the Azure portal and show you this solution actually running in Azure today, and we'll walk through it step by step and see how it's built. Perfect, there we go. So let me flip over here. There we go. Great, OK. So we'll start in the Azure portal. And if you want to build one of these analytics pipelines, the way to start is by instantiating a data factory. A data factory, think of it just like that manufacturing plant. When you create a new data factory, it's like having an empty manufacturing plant. There's no assembly lines anywhere. It's just like an empty building. And so when I go and say I want to create a new data factory, you're effectively creating the start of your manufacturing plant. A new data factory is not reusing any resources. It's free to create data factories until you start putting pipelines into them. Creating a data factory takes a few seconds. It's just a metadata operation. And so I'm not going to create a new one, but instead what I'm going to go do is open one that I've already created that has this solution running, and we'll look at it. So here I've got my customer churn data factory loading up. On the home blade of a data factory, you get kind of an at-a-glance view of what's in the factory. We just talked about what data sets are. Those are all the concrete pieces of data we'll work with. Pipelines, again, are just sequences of activities. The one thing I didn't mention was linked services. Linked services are very simple. They're just the other Azure services or other services that we've linked to the data factory that it can communicate with. So if I look at this, you can see what I've got here is I've linked to the factory a couple of Azure storage accounts, an Azure DB, an Azure machine learning account, and then finally a Hadoop cluster. And this is just all of the services that are being composed into my pipeline by the factory. If I wanted to work with some more data, maybe I want to work with an Oracle database on-prem, I can go and add my linked service to that Oracle database, maybe an on-prem file share, et cetera. And so through here, I can start to link to more. What you'll see is more inbox connectors to various data sources added each month as we go. And there's support in Data Factory, as I mentioned before, for moving data, connecting to data sources, whether they be on-prem or cloud. The on-prem connectivity is facilitated through something we call the Data Management Gateway. You can set up those gateways right through the cloud portal as well. It gives you a piece of software to install on your side of the firewall, and it helps manage communication. So let me roll back. So now I've got a data factory. It's linked to some HDInsight clusters, some storage accounts, SQLDB, et cetera. And I've got some pipelines created. The best way to work with a data factory, if you're coming into one brand new, I often suggest people to go and click Sample Pipelines. What this will do is deploy one of our end-to-end samples right into your factory so it can be up and running and you can see how everything works. It's a great way to get started. But in this case, because I've already deployed this customer churn scenario, I'm going to start with the diagram view. The diagram view gives me a complete look at everything that's deployed in the factory. It's an infinite canvas kind of thing so that you can have as many pipelines as you want in a single factory, as many data sets as you want. There's no scale limits from that perspective. And the idea is that the diagram view shows you exactly what's deployed and what's healthy and running in terms of pipelines in your factory. And what I'm going to do now is kind of take you from left to right on this pipeline and show you how it's built. This is mimicking what we just looked at in slides. OK? So let me zoom in and walk it step by step and show you how this is built. Big enough? Yeah, great. OK. Let's go one bigger. There we go. All right. So on the far left, we're not actually collecting data live from cell phone towers. As I mentioned, we could hook up a live ingestion from file shares if we wanted. There's extensibility points to be able to connect to other stores. So what we've done is we've just added something on the far left that is mimicking the generation of cell phone log files or call detail records. This is actually, believe it or not, a piece of Python code running on a Hadoop cluster. And so just for fun, we used Python running on Hadoop to generate the data. But a typical pipeline would start right here. And it would start with that log data, a single data set that's representing all of the log files for a particular month from my telco. So maybe all the log files from January, then all the log files from February, et cetera. And the way you do this is you basically specify just a JSON document. A JSON document tells us where the data is, what its structure might be, where it's located. And so what this data actually looks like in Blob Store is it looks like this. This is kind of a typical call detail record, just a bunch of semi-structured log files about who called what, where, how long, et cetera. And the way I describe that in terms of a pipeline in a factory is through my data set. If I double-click the data set, it's going to give me kind of a live view of how healthy that data set is, has it been generated, et cetera. I can look at the source for the particular data set. So we have an editor built into the portal as well, so you can look at the definition of a data set. You can edit it. You can deploy new ones, et cetera. But I've copied one out just to kind of inspect in a little more detail. But what I'm going to do, sorry, I forgot. What I'm going to do is I'm actually going to look at the data set over here. And so what's happening in between this piece of data and this piece of data is one step that is just partitioning the incoming data. So if you think of these log files as coming in all the time, being landed in maybe one container in Blob Store, this one step in this pipeline is just taking the data out of that container, taking all the logs for January, putting it in a January folder, taking all the logs for February, putting it in a February folder. And it's accomplishing that task at scale by running a Hive script on an HDInsight cluster. And so if I go down here, you can see the activity is actually a piece of Hive code. It's running on an HDInsight cluster. So that's happening at scale. I'll dig into one of the subsequent Hive scripts in a little more detail. So I'll just kind of glaze over this one for now. And so at the end of it, what we've got is data that came in one container. We've partitioned it, so it's ready for kind of longer-term storage. And then what I'm going to do is I'm going to dig into this pipeline and these data sets a little more detail so that you can see. So partitioned CDR data, it's in blob storage. Let's look at how you create an actual data set. Here's the definition of that data set. It's just a simple JSON document. You can do this programmatically. You can do it through the UI like I showed. But what I wanted to show you is kind of under the covers how simple these things are. And so to create a data set and add it to Data Factory, you create a simple JSON object, you name it, and it's got three sections: structure, location, and availability. Availability is just saying kind of what the frequency is that this data set is being appended to or updated. And so you can think of this as time slicing of the data set. So if you imagine that these log files is one big, long data set, we're basically saying it's sliced monthly. So there's the January partition, the February partition, et cetera. We're asserting some structure about this data set. Just like in Hadoop, you've got a bunch of log files sitting in Blob Store. And so you're effectively asserting structure about, or schema about what's in that what's in those log files. And I've actually shortened this just for the sake of the demo. But the idea is that here's the first column and its type. Here's the second column. And I've removed all the other columns just so I don't scroll through the 30-column, I think, or so wide schema definition. And then lastly, this is the kind of meat of the data set definition is location. And so a data set is just a pointer to a piece of data. You're saying, oh, this data is in blobs. This data is partitioned by year and month. You can see there's a variable here. It's a comma delimited file. And here's the partitioning scheme. And what we're saying is this data is partitioned by year and month. And we're using one of the environment variables we inject into the system called slice start. There's also one called slice end. And so if you remember, I said this particular data set is sliced by time. What we mean by sliced by time is each time there's an activity that runs to produce this data, that activity is going to run monthly in this case. And so slice start would represent like January 1st here. Slice end would represent like January 30th. And so what's happening is we're just defining the data set and how it's partitioned. Lastly, we're saying this data set, while stored in Blob Store, is stored in this particular linked service. So what we do is we have a generic definition about the data and where it's stored in a particular kind, in this case, a blob storage. And then this last binding to a linked service is basically binding it to a particular blob storage account. And so at this point, all I've done is describe the data that's going to be used by the subsequent step in the pipeline. So if I go back, I've got this step that's taking that data set as input. It's also taking another data set called mobile customers as input. This data, just for the sake of the demo, I've pre-staged it into Blob Store, but I could be connecting this up to an on-prem data warehouse and pulling the data from the on-prem warehouse using the movement service provided in the factory. But just for simplicity, I've removed that from the demo for now. And so I've got a pipeline taking two data sets and producing one data set on the other side. What it's going to do is take those log files, as I mentioned, that is a bunch of log files for a month that describe all of the call activity, and it's going to aggregate it down to create one row for every customer and say, you know, OK, out of all the logs, we're going to find all the records for Mike. We're going to generate one row for Mike and say Mike talked this many minutes in the month. He had this many drop calls, et cetera. And we're going to combine it with the customer data so we can basically resolve a SIM card ID to an actual customer name. And that's going to be done, again, by a processing step in HDInsight. HDInsight is a fantastic tool for running data chunking at scale. And so inside of this pipeline, sorry, I just double-clicked to have this open up, I've got two steps. One is a Hive activity followed by a copy activity. The copy activity I didn't really need to do. I just did it to rename the file. But The Hive activity is the meat here. This is something that's going to be spun up to process all of those log files and aggregate the data. Basically, what I'm doing is I'm preparing the data for input to a machine learning model. If you want to look at the actual Hive script that I'm running, you can click Pipeline Source. Pipeline Source will take you to a definition of the pipeline and subsequently to the Hive script. But if I double-click on the Hive here, and I click Activity Script, you'll see this is just a typical Hadoop Hive script that's going to be run to work with the input data sets. One interesting thing you can see is that that Hive script is parameterized, just like you'd parameterize SQL queries in an app. You parameterize the Hive script to take the frequency information, like, in this case, we're running monthly, so you take the fact that, what the year is, what the month is, et cetera. You can download the Hive file, et cetera. If you're new to Hive or you're new to Hadoop, there's a lot of other sessions at the conference that will talk you through and work you through kind of all of the things you can do with Hadoop and HDInsight. What I want you to take away from this talk is that you can use all of these services together into a pipeline. So I'm not going to dig into the Hive in too much detail. Lastly, what I want to do is show you this particular pipeline stage and show you how you go about defining a pipeline in Data Factory so that you can see how these data sets are taken as input and then produced as output. So again, if I double-click the pipeline, I can go to Pipeline Source. That will take you to the web-based editor for the JSON document that represents the pipeline itself. I've just copied this out into my Sublime text here so that we can look at it in a little bit higher, bigger font. So let me drop this, come over here, and here's the pipeline definition. So this is the definition for the pipeline we were just looking at. Again, it's a simple JSON document, because all you're doing is declaring that this data set is coming as input to this particular Hadoop task, and it's going to produce this output. And so you just have to declare that to the system. What you do is you give it a name. In this case, I'm saying aggregate mobile customer usage, so I'm aggregating those logs. I give it a description. I set a start and end date. This is just like scheduling a reoccurring meeting. You say, the reoccurring meeting is going to start in January, end in December, but it's going to happen monthly. And so there'll be 12 instances of that meeting throughout the year. And then lastly, what you do is there's an array, and there's one object in the array for each step of the pipeline. And so in this particular case, I've got, I've split the whole thing into a few pipelines. So let's drill in and see what one step in a pipeline looks like. And again, one step is just a JSON object. And the first thing I do is I name my step, and it's going to be aggregate mobile usage minutes. That step is an HDInsight activity. It's going to run on the HDInsight cluster that's represented by this linked service. I'll come back to how you define a linked service in just a second. And what actually is going to run is a Hive script that's located at this location in Blob Store. And this is the Blob Store it's located at. And these are all the additional blob storages I want to have automatically bound to my Hadoop cluster when this particular Hive activity runs. So there's a lot of configuration you can do here. I've shown a little bit of the power. There's a lot more. And so you're effectively saying, run this Hive script once a month on that input data. And then there's a section called extended properties. Extended properties are just any variables you want to pass in to your particular Hive script's execution. So each time it executes, in this case once monthly, these extended properties will be passed in. I've defined a bunch of them here. And you can see what I'm passing in here is year, month, day. And I'm taking that from the slice start variable that's kind of an environment variable that's injected by Data Factory. So I'm passing into the Hive script the fact that, hey, you're running for the January run of 2015 right now. And so I can parameterize my Hive script to take that as input. Lastly, I specify the two data sets that will be used as input. The reason we have this level of specification is because we can do interesting things, like automatically do precondition checking on those data sets to see, are they available, are they meeting certain preconditions, so that we don't waste time and resources spinning up HDInsight work if the input data just isn't ready, or it's not matching certain preconditions that you've specified. And I'll talk about preconditions a little bit later in the talk. And then lastly, you say output. Well, this is what the output of the Hive script is actually going to generate. It's another data set in blobs. And then we've got a set of policies you can state for that activity. I've put the simplest policy here, which is just a retry policy, which means when we spin up that activity, this Hive script, and run it, If it fails, do you want us to retry for you? If so, we'll retry the activity. You can do all kinds of things here, like have timed backoffs in when you want to retry. You can specify what to do when data arrives later than you expect. So let's say you go and want to run at the end of every month, but a certain amount of input data isn't available. You can give us all kinds of policy that you want us to do and how and when we run these activities for you. And then I've got another activity along the way as well. So that's how you go about specifying a pipeline. It's just a JSON document, one object for every activity, and you just declare what activities you want to have run and where you want to run them. I'm going to go back to this linked service line, which was saying, run this Hive script on this HDInsight cluster. And this HDInsight cluster is defined by a linked service. A linked service, again, is just a simple JSON document. And what you're saying here is, I'm going to run on this HDInsight cluster. I want the cluster to be HDInsight version 3.1. I want the cluster size to be 2 nodes or 200 nodes or whatever you choose. Basically, any configuration you'd want about your HDInsight service. And then lastly, we specify type. And type here could mean one of two things. You can, for a lot of our processing services that we support in Data Factory, we have one of two modes. The first mode is you've created the resource up front, and you've effectively given a connection string to Data Factory. And you've said, go and use this resource. So in this case, you would have created your HDInsight Hadoop cluster, and you'd given us the connection string. However, in this particular case, what I've specified is to use what we call our on-demand HDInsight feature. On-demand means let Data Factory take care of provisioning the Hadoop cluster for you when it's needed and deprovisioning when it's not needed. And so you can now start to create these pipelines that use HDInsight, use virtual machines to run custom code, et cetera. And the pipeline will take care of provisioning the infrastructure to run that script when needed and deprovisioning the infrastructure when not needed. So you're completely out of the business of any kind of infrastructure management of Hadoop clusters and VMs and whatnot. You just give us code you want to run and where you want to run it, and we take care of spinning it up and spinning it down on your behalf. If we need to retry, we go get it back, et cetera. And so it's a nice feature from that perspective. It really lets you kind of focus on the various processing steps you want to have happen. So let me jump back out into into our pipeline again. So we've got incoming log data. We've got customer data. We've merged it. We produced another data set, which is basically one row for every customer for that month. And then lastly, I want to show you two more steps. I'm going to take that data set that's in Blob Store that's one row for every customer in the month, and I'm going to feed it into a pipeline that has one activity in it. If I double click, you can see down below what's actually running inside of that pipeline is an activity, but this time it's an activity that's going to call an Azure machine learning model. So just like in the prior pipeline, we were using the Hadoop service to run some HDInsight to prepare and aggregate data. This time, we're going to call an Azure machine learning model and say, hey, the output of that Hadoop job, once that's ready, I want you to feed that into a machine learning model. And that machine learning model is going to take that output and effectively add one column, the likelihood of that customer to churn. And the way that all that works is by using one of the machine learning models that's available in the machine learning gallery. A fellow on our team made it for this demonstration. It's called Telco Customer Churn. It's a machine learning model that looks like this. You probably saw it, machine learning introduced by Joseph in the keynote earlier today. This is a model that's been built and built and trained based on telco usage logs. And so the idea is that you can feed logs through this model, and it will, with pretty good accuracy, determine is this customer likely to cancel their subscription or use less based on the training data that was fed through this model. And the training data is effectively data of logs of customers that actually canceled or used less. And so it used that pattern and that recognition to figure out which customers are likely to churn. And so I'm certainly not a data scientist, and so I'm not going to walk through what all the steps are within this model. But the idea is that as a developer, what you can do is you can work with the various models that are available, compose them into your Data Factory pipelines, and use them just as a web service. And so the way we actually built this is we had one of the data scientists go create this model for us, and he tuned it, and he tells me it's very accurate. And then he goes and he prepares this model as a web service, as Joseph showed in the keynote. And then as a developer, I can just use this by calling the web service. And the way it works is it's using a batch scoring approach, which what that means from a machine learning perspective is that I call the web service and I tell the web service where in blob storage the input data is. So I don't shuffle the data to the web service over HTTP or anything like that. I simply call the web service and say, please score all the data in this file in blob storage and put the output over here. And so that capability is natively built into ML once you create a web service based on your model. So as a developer, I didn't need to know all of the two-class vector support thingy-majiggers that are going on in here. Instead, I needed to know how to call that machine learning model and the schema of the input data that was required. And so from a data factory perspective, I just added in this step to call that model, and I told it, take the data from this blob store, write your output to this blob store. And then lastly, I created a step that said, copy the data from, sorry about that, copy the data from blob storage to SQLDB. OK? So you can see on this side, the data is in blob store. On this side, it's the same data that I'm moving over to SQLDB now that I've created that interesting result set that is telling me the customers that are likely to churn. There's one thing I want to show you about that copy activity, and then we'll look at the actual data. This copy activity, the interesting is, what's actually performing the copy under the covers? Well, inside of the Data Factory service, we have a globally available copy service that basically moves data among Azure stores, from on-prem to Azure, et cetera, so that all you need to do to specify data movement is to come and say, well, it's this data as input, and I want this thing as output, maybe in this case from blob to SQL. And you don't worry about spinning up VMs, when the copy will happen, retrying the copy. The system just takes care of it for you. And so the copy in this case is as simple as saying, this data set is input, this data set is output, go. And if you want to do some type of projection during the copy, like, hey, only take these 3 columns from the input set and put them over here, you can. And you can specify that projection just in the JSON document. In this case, I'm just doing a straight copy. And so I'm saying the source is blob storage, skip the first line because I've got headers in the first line. And the destination is Azure SQL. And actually call this stored proc on the way into Azure SQL. So I want that to be called instead of directly writing in. And here's the input and output data set. And I just put that into my pipeline. The copy happens for me. So it's a nice facility that's offered inside a data factory. And so now, if this thing all runs end-to-end nicely like it's supposed to each month, what I should be doing is going from the data that looks like that and that structured customer data to some structured piece of data that includes the likelihood of churn for each customer. And so if you recall here, our output is a data set in SQL. If I connect to that database and run a query against that table that's being copied to by the pipeline, and I select out a few of the columns, and the last column I'm selecting out is scored probability. This is the column that's added by the machine learning model. What I've effectively done is I've aggregated all that log data. I've predicted using the ML model, and this is the output. And to data people, this is a finished good. And we'll look at how to create reports in a second. So what you've got here is this data was coming from that structured data, the customer list. This data is a bunch of aggregation that came from the logs themselves. And this particular data is data that came from the machine learning model itself. So effectively, what it's saying is customer 72963 of age 79 is a female. She had a 6% drop call rate that month. She had a 1% failure rate that month. She talked 81 minutes. And she has a 92% likelihood of churning. And it's not just these factors that went into the model, but I've just selected out these 3 so that you can kind of see the structured result set that came out the other side into the DB. And so what I wanted you to take away from one of these pipelines is that the idea is being able to work with and collect all of the interesting data, use the appropriate Azure service of choice to operate and transform on that data, whether it's Hadoop, custom code on a VM, Azure ML, et cetera, and then push that data to the store or place that it can most easily be consumed, and then have that run consistently, hour in, hour out, every month, every week, whatever the cycle is that makes sense for you. In this case, we've got this thing running monthly. And then lastly, obviously, once you've got something into a nice structured form like this, you can go and create snazzy-looking reports that represent all that data. And so we quickly went and created one that was a Power BI visualization. Power BI is one of our new analysis tools. And all I've done is graphed that customer churn data. So I can drill in. This is just talking to the database that's being updated by the pipeline. And I can say, oh, good, most of my customers in blue here aren't likely to churn, but the ones in purple are likely to churn. Let's kind of drill in and figure out why that might be. Well, it turns out it has nothing to do with the type of job they have. It actually has nothing to do with the type of education they have. But people in this particular state seem to be showing more likelihood than this other state, so let's start drilling in there and seeing what was happening maybe in the infrastructure in that place. So you can start to drill in, get more insight into what was happening, what was causing these people to start churning, and you can visualize that data in interesting ways with Power BI. But from an analytics perspective, what we want to take away is that you can build these pipelines, you can operate them, you can get kind of a complete end-to-end view of the data, and then have them run on a regular basis. And so let me jump back into our slides here. There we go. I'll skip this one really quickly and just give you a quick summary of Data Factory, what it is. It's a service to let you orchestrate, schedule, and monitor existing Azure services. And so you can compose them together to create pipelines like this. It does automatic infrastructure management. I showed it for Hadoop. Quickly, you'll see it coming for custom code on VMs. It has a movement service built into it to easily facilitate movement among your various stores, both on-prem and cloud, and we'll be adding new connectors each month. We just finished adding the Oracle connector and the on-prem file share connector. And then lastly, it provides you a single pane of glass, one place to log into to see how your data is moving, how it's being transformed, how things are going. And I'll show an example of that in a little larger Data Factory in just a second. In terms of a few other scenarios that we've been seeing people wanting to build out these types of analytics pipelines are things from generating product recommendations for websites. If you were in one of the earlier modern data talks, you saw how big data was being used to augment the search results in an Azure Search Index. Typically, you'd be running that on a schedule every day, all the time, to be augmenting the data for those search results. Another class of usage that we see a lot is what we call operational excellence scenarios, where people are building telemetry systems where if you think about any kind of SaaS application or device that you might be monitoring, these devices are constantly emitting all kinds of data and information that you need to aggregate, predict on, et cetera, to determine what's the availability of your services, what are their latency, what are customers doing with it, et cetera. And so we see a lot of SaaS application builders through to industrial automation companies using Data Factory and Blob Store and HDI and ML to ingest all of the telemetry information from their website through to their oil and gas pipeline, and then creating just series of pipelines to work on that data, transform that data, give you different views over it to kind of get more insight out of those systems. And so what I want to do is log into one other Data Factory that represents one of these telemetry systems to give you an idea of the types of things you can do as these systems start to grow up. Great, we're back. So let me jump out of this customer churn demonstration and jump into a different one I'm going to call the Data Factory Data Lake. Let's get it to come up. Great. You can see this one's a little bit bigger. It's got 154 data sets in it. Let's go to the diagram. What this is actually, this is the Data Factory we use to run Data Factory. So worldwide, this Data Factory service is up. We're collecting logs all the time about what pipelines we're running, what we're orchestrating, what's up, what's down. And we use a Data Factory to ingest all kinds of telemetry, from commerce telemetry through to usage telemetry through to our live site telemetry. And we munge all that together to figure out what our users are doing, what their experience is like, what's working well, what's not working well, et cetera. It's effectively how we run and operate the Data Factory service itself. A lot of other Azure services and Microsoft services do the same. And what I want to show you in this factory is how these things kind of grow up over time. This particular factory is actually not that old. And there's a lot of stuff going on in here. Some people say, man, that looks ugly. Why did you lay it out like that? Like these lines go over. Well, it turns out this is the way our telemetry team likes it laid out. It makes sense to them. What we're trying to do with Data Factory is give you effectively a live Visio canvas or a live diagram of exactly what's deployed, how things relate to each other, and let you organize it, collapse it, expand it, however you see fit. And so gone are the days when you decide to design a data integration project, it gets written on the whiteboard or put in a Visio document of some kind, and that's the last time you ever see a pictorial representation that's up to date. With Data Factory, what we're trying to do is say, you've got a live diagram of all of your data integration overlaid with health information and usage information that you can log into. You can customize its look and feel to however makes sense for you. It's yours, but it's up to date, it's live, it's an accurate representation of the system. If I drill in, you can see, well, I've got some stuff that's red. So something in our telemetry system is not working well. You can maybe ask me why our telemetry system has red, but that's a conversation for another day. And I can start now to kind of at a glance drill in and say, hey, through this fairly complex network of pipelines, what's going on? And so if I drill in to one of these data sets here, and double click. And you can see this particular data set, it really hasn't had one of its time slices be fulfilled in quite some time. So you're kind of looking at what's going on here. So if I drill into one of these, you can see we've had a bunch of retries that the system's done for me automatically. Every one of those have failed. And their status is failed validation. And the error message says, a blob at this particular location does not exist. That's pretty small. I don't know if everybody can see it. It says, a blob at this very particular location doesn't exist. This is just showing you some of the simple validations that are available in Data Factory where you can say, look, I need this input data. I'm going to ingest it into my pipeline. If it's not there, or it's smaller than a particular size, or it hasn't been updated since a certain date, then it's not useful to me. And so don't even start running the pipeline. Just fail validation up front. Something's wrong. And so in this particular case, we're expecting a partner team to be putting a file there for us to consume. That file hasn't been put there for a while. And so the pipeline is not starting. It's failing validation, and alerts get sent to us automatically that a particular stage in my pipeline has failed. Once that stage gets fulfilled and the condition gets met, Data Factory has a bunch of features for you. So you can come in and say, OK, rerun that pipeline as if it was 3 days ago when it started failing, and then cascade that all the way down. So anything else that's waiting on that gets kicked off as needed, when needed, et cetera. And so there's a lot of nice features built in Factory so that you can kind of manage a larger data graph or a larger telemetry system like this. So that was just a quick look at kind of what a larger system starts to grow up into. And again, this becomes a system that you can customize. So if I take the lock off, I can start to drag things around and make it my own. Multiple people can edit the surface however they see fit. I will undo that because people get mad at me when I change their work. And come out. Sorry? Oh, there was a question that said, could I print that? Today, we don't have a feature in Box that will kind of print it and lay it out nicely. It's one that we've heard a lot, though, so we'll look at doing an export of it for print in some way. And so that showed you a couple other factories really quickly. Let me now jump back to slides, and we've got a couple of minutes left. I need to be taller. I can't see the time thing. This clearly wasn't a stage made for me. All right, so in terms of roadmap, I showed you a little bit about what Data Factory can do for you today, how to create pipelines. Things that you'll see coming in this area in the future is that you'll get a lot more authoring support. You'll see Visual Studio integration. You'll see pipeline templates. So you can create pipelines like the one I showed from a template and then just fill in the missing pieces. You'll see a lot more connectors coming to Data Factory. There's some coming in the coming weeks, and we'll be adding them weekly from here out. There's connectors coming for Azure Document DB, Search, SQL DW, Data Lake, all the stuff that you've heard about, so you can efficiently move data among these sources and create pipelines that span them. There'll be additional activities so that you can execute stored procs in SQL DW through to a bunch of interesting stuff coming in that space. There's some work we'll do to make it easier to handle reference data, like that customer list we were looking at. There's a bunch that's coming in terms of improving and adding to that monitoring view, so you can really have a single pane of glass to see how your data is moving, how it's being transformed, whether it's healthy or not. And then lastly, what I showed you today was how to create a pipeline that used a lot of processing services in Azure, a lot of the storage systems in Azure, but we're opening up the entire system of Data Factory so that if you want to go and add in a new processing system, what I mean by processing system is something like HDInsight or something like Azure ML, you can go add your own. You can go add support for your own. So we're working with partners right now that have Spark as a service and other processing platforms. And they're adding support for those platforms into Factory so that you can create pipelines that span all kinds of different systems to basically use the right tool for the job, for your various tasks, and then easily stitch together or compose these various systems into a pipeline. And so there'll be an extensibility SDK that we'll release. It's already available in limited preview right now. As I mentioned, we're working with various partners that both have systems on-prem and in the cloud so that you'll be able to truly create hybrid pipelines and manage and monitor them from one place. And so that's an exciting new area that's coming in Data Factory. Just kind of whet your appetite for it. If you're interested in learning more about that, feel free to ping me. And then lastly, geolocation. Today, you can create a Data Factory in one of the Azure geolocation, one of the Azure regions. From that region, you can orchestrate things across all of the rest. And so you can create a pipeline that works across all the regions today. You'll see Data Factory, the orchestrator of Data Factory, be available in other regions in the coming months as well. With that, I thought I'd provide a few resources. This is one of the first sessions we've done on Data Factory and how it can combine. So what we tried to do is provide a lot of resources if you're interested to dig in and learn more. Hopefully, it kind of whet your appetite for things you can do. There's a lot of good documentation on windowsazure.com. We've got a GitHub repo just for Data Factory samples. We are all ears on what you'd like to see for samples. We've uploaded some. We change them all the time. We'll probably put this customer churn example up there as well in the coming week. There's a place to ask questions. There's a place to ask for new features. There's a lot of financial services companies. You can imagine do all kinds of interesting things with data. We've taken the best of what we've learned from them so far with Factory and encoded that in an architectural pattern, what we call a blueprint. That's going to be published later this week. So if you want to see what some of our customers like Milliman is doing in terms of actuarial automation using Data Factory and HDI and Blob Store, you'll be able to see kind of the best practices we've extracted from that. And there's a set of other case studies available here on what customers are doing to create analytics pipelines using Azure today with a lot more to come. One thing I'll note is that Data Factory is currently in preview. We have a number of customers running in production already. It's a service we've been running inside of Microsoft for a while now, running production loads for some of our biggest services, whether it's Xbox, Microsoft Studios, through to our Microsoft Intune services. All of them run and are powered by Data Factory today, so we're pretty confident about kind of how battle-hardened it's become inside the company now that we've started to bring it outside. With that, I wanted to thank everybody for your time. I really appreciate it. I appreciate getting to talk to you about data. I'll be available at the booth for the next couple of hours after the session. But I think we have a couple of minutes, so I'm happy to take any questions that people have, and I'll stick around for a few minutes after that. Thank you very much. I appreciate it. Thank you.